Well, hello, my algebros. Here's our last study guide video for the whole semester. I really will miss having all of you guys. It's just been a lovely, fun year, a lot of growth, and I appreciate all your hard work. So let's get to it so you're ready to go. So on this first question, this is from chapter 6, we need to remember to always take the ticket when we have a negative exponent, and only the exponent that's negative, that's attached to the base, has to move. The other one doesn't. So a ticket, you got to take it. If you don't have a ticket, you don't get to take it. So only the x moves downstairs. Once you move it, you take away the ticket or the negative. Number 2 is solving, and to solve we always use SADMAP. So here we're going to see if we have to add or subtract. We add the 4 to both sides. Then we look about multiplying or dividing. We go ahead and divide off the 2, which brings us to the e, which is exponent, and the inverse operation would be square rooting. So we square root both sides, and we remember that a square root could be plus or minus that value, because it could be 5 times 5 or negative 5 times negative 5. All right, number 3 asks us what degree this is, and to put something in standard form, right? Standard form means that we have things in exponent from largest to smallest. So the first number here is going to tell us what this degree of this exponent is, of this polynomial, and it's to the 4th degree. And if it asked us for the lead coefficient, we would say negative 2. Number 4 gives us a point and a slope, and if we have a point right here and a slope, how would we write the equation of the line? Well, we use the point-slope form. Once you have the point-slope form, you substitute in your x1 and your y1 into the correct places and your slope. So we have y minus y1, which is 2, equals our slope, which is negative 2, times x minus our x value, which is negative 6. And now we just solve for y. So we know it's a double negative. We distribute the negative 2, and then we add 2 to both sides to isolate y, and we get y equals negative 2x minus 10. On number 4, we see that we have 2 radicals that are being multiplied. So the fraction rule applies here, where you multiply the bases, right? So 2 times 6 is 12, and x times x is x squared. Now we simplify to see if we have any perfect squares in here. 12 is 4 times 3, or 2 times 2 times 3, and x squared is x times x, revealing that we have 2 perfect squares in here, the 2 and the x. And the 3 does not have a partner or a match, so it stays inside. On number 6, it says to factor. So we're not solving or anything, we're just factoring 2 numbers that multiply to be 10 and add to be negative 7. Has to be both negatives, because a negative times a negative is positive, and a negative plus a negative is negative. So we get negative 5 and negative 2, and again we're just factoring it. We leave it factored, we're not solving. Same with number 7, this is a difference of 2 squares. If we can square root the y, and it's different, which means positive and negative, and square root 25. On number 8, we go ahead and first label our vertex, which is going to be 7, 8. And that tells us that the x value is the axis of symmetry, where the y value is going to show us the maximum or minimum. And if it's a negative parabola, then it will be a maximum. If it's positive, it will be a minimum. So filling in the blanks here, we see that the vertex of this point shows that the y value 8 of the function is the max. Number 9, to complete this value so it's a perfect trinomial, or to complete the square, we take the b value and we cut it in half, and we square it. So of course it would be adding 25 to both sides. On number 10, it asks us what numbers are solutions. So first we're going to X box. Two numbers that multiply to be negative 20 and add to be negative 1 are going to be negative 5 and positive 4. But this one asks us for solutions, which means we have to solve when they equal 0. So we'd obviously add 5 and we'd take away the 4. Number 11 is what is the slope of this equation? Well, of course that was if it's in y equals mx plus b, where m is the slope. So we have to solve for y in order to do that. So we add the 4x and we divide by 2. We get y equals 2x plus 6. So 2 will be our slope. Number 12 asks us to see what the solution would be here. And in this scenario, we're like, oh, let's eliminate the 6's. So if we do that, or the x value, sorry. So I multiply the second equation by negative 2. And I go to add it to the first equation. And I find out that this will actually be a infinite many solutions because it's a true statement. And there's not one solution. 13 then asks us if we have, using the same idea to write a system, using a algebra teacher who drove by a farmyard full of chickens and pigs and just happened to notice that there was 100 heads of the chicken and pigs and there was 270 legs. And chickens have 2 legs and pigs have 4 legs. Now we have our two equations. We can eliminate. I decided to eliminate the chickens, multiplying the top equation by negative 2, so that when I add them, I find out that the pigs are going to be 35. And if the pigs are 35 and chicken plus pigs are 100, then we simply subtract 35 and we find out that the chickens are 65. Number 14, we can see that this system has been solved by graphing. Two equations of these lines are graphed, and we see that the x value is 4 and the y value is 5. Give a value that is not a solution to this inequality. So first I need to solve it using SADMAP. So I add the 6 to both sides. And I go to divide by a negative coefficient, which means I have to switch the sign. So I get x is greater than negative 5. So now I want solutions that are not going to be bigger than negative 5. So things that will not be bigger than negative 5 will be negative 5, negative 6, negative 7, and so forth in that direction of the number line. Now let's say I had to find out what solutions would be. Well, solutions would be anything bigger than negative 5, which would be negative 4, negative 3, negative 2, and so forth. All right, number 16 says to solve for the x-intercepts. Now remember back in the day, we would make a t-table, and if I wanted the x-intercept, I have to have y be 0. If I want the y-intercept, then x had to be 0. But this is only asking for the x-intercept, so y will be 0, and I substitute that in. And I go ahead and solve for x because it will eliminate the y value. And I find out that x is just simply 5. Number 17, it says to graph the two inequalities, these two systems. So I graph the first inequality, seeing that it is not a solid line. The slope is just a 1. So I shade that in, and then it says that y is greater than 2. So I shade in everything bigger than 2. That's why it shades above the line. When I graph the second equation, first I have to have it in graphable form. So I go ahead and solve for y, moving over my 4x, dividing by negative 2, which means I have to switch the sign. And I go ahead and graph the equation. I need to see this as y is greater than or equal to negative 4. So I go ahead and grab that line and I shade above it, and then I have to solve for the next one, getting y is greater than negative 2x minus 4. So I put in my negative 4, and my slope is negative 2, and then it has to be all things that are greater, right? Y is greater than negative 4, which means I'm going to shade above, right? When I do that, I see that the double shaded area is the purple, and you can pick any solution from that area. I'm just going to go with like 4 and 6 in here, right? We put it in pink. 4 and 6. And I know that is in the double shaded area. So I could put, like, what's the solution? 4, 6, as long as it's in the purple. What's not a solution? Well, 0, 0 is not a solution because it's in the pink, but it's not in the purple. So anything that's in both is a solution. Anything that's not is not a solution. All right, number 18. What is the slope of the line that could be perpendicular and parallel to this line? And it says y equals negative 19x minus 4. And it's all about the slope, you guys, all about the slope. So a perpendicular slope would be opposite and reciprocal. So we would turn the fraction upside down and we would make it become positive. Parallel lines have the same slope, so it would just be negative 19. On 19, we have to see the equation of the line. So first I have to see what it goes up by consistently on the y-axis, and I see it goes up by 3. I would then multiply that on the other side to see what my y-intercept is going to be. So I put in it's 3x times something times 1 will equal 5. So I substitute it in, and I see it's 2. So I know that my y-intercept will be 2. 16, I have to find the difference here. So finding a difference means I'm subtracting the second equation, where I can apply a negative 1. And then I just combine my like terms. I like to stack them up to make sure I don't make any mistakes. Combine those like terms. 21 is a division problem, so I need to do keep, change, flip. So I keep the first and I factor it. Downstairs, I factor that as well. Then I change the sign to multiplication and I factor. So I'm moving 9x squared minus 18x, taking out a GCF and moving it downstairs, where I take out a GCF of 3 and then I Xbox to solve and put that on the top. Now I can simply cancel out like terms until I end up with 3 over 9x, and it's x plus 5x minus 2. So I can still reduce that by 3. All right, 22. It says to evaluate. I'm first going to apply my rules for this. So I want to take my ticket. I would use the 0 exponent, which means it just turns to 1. And then I go ahead and take my ticket. And now I can substitute the value for x into this equation, which is 2. So I have 2 to the 5th power under 6. So I'm going to go ahead and factor this out. And then I see they both have a 2 on top and bottom. Take that away and I get my final answer. 23, I'm going to simplify this radical by derationalizing it, multiplying the bottom equation by square root 5 and the top equation by square root 5, which just means it becomes 5. So that means I have, on the top equation, I have 10 times 25 is 50, so I go ahead and factor that out. Factor out the 5, so I end up with negative 2 times 5 and square root 10. Downstairs, that would make it 3 times 5, which is 15. And now I can reduce this fraction, canceling out the 10, and end up with negative 2 square root 5 over 3. 24, I need to simplify these first to see if I can get a common base. The green one is the first problem, the purple is the next. Then I have red and blue. And I go ahead and take out the perfect squares here. Like this had just one set of 2's. Same with this one, same with this one, same with this one. Now I see what bases I have left over, and I see a couple have square root 10, so I can combine those terms, and then the others cannot be combinable. All right, 25. What is the vertex? Well, I know what the vertex, if I want the x value, it's negative b over 2a. And then I just solve for y by substituting into the equation. So I identify my a, b, and c, and I go ahead and solve for my x, because x will equal negative b over 2a, negative 16 over 2 times negative 2, that's my a value, and I do the math. And I get 16 over 4, which is positive 4. So now I want to solve for the other part of the vertex, the y. So I use the equation to do that. It says y equals, if only had an x value, which we already solved for, and I substitute that in. So I get negative 2 times 4 squared plus 16 times 4 minus 15. So I end up with negative 32 plus 64 minus 15, and our net value is 17, just positive 17. So the point would be 4, 17. 26 asks for the product of a binomial times a binomial, x plus 5 and 3x minus 2. So I'm going to go ahead and use box method for this and multiply the two sides together. And then I combine my like terms. All right, 27 asks me to say the equation of the line. That's y equals mx plus b. So first I need my y-intercept, which is right there is negative 3. My slope is my rise or my run. So I start at that point to get to the next point. So I'm rising up 2. Sorry, that's not right. I'm rising up 3, and I'm running 6, which means I need to reduce that fraction, which will be 1, not third, but 1/2 x minus 3. Okay, on 28, you're going to do your own fraction rules. This is my little sample. I know to add, I have to get a lowest common denominator, and then I add or subtract the numerators. So I have a little value that I do this with just letters. A over b plus c over d, getting a common denominator, multiplying the top what it's missing, and then I combine the like terms on the top. Multiplying fractions means I multiply straight across, and then I reduce if possible. This is not reducible. Here's in real numbers, 1 times 1 is 1, 2 times 4 is 8, and that's simplified. To divide, I use my keep, change, flip. So I would keep the first, change the sign to multiplying, and flip the second, and multiply straight across, just like I did before. And reduce if it's possible, right? Here's one that's actual, 1/2 divided by 1/4, which means 1/2 times 4 over 1, multiply across, and reduce to 2. On the last question, this is all the factoring methods here. So I have some that I put down, the GCF, and I gave an example of taking out a greatest common factor. Grouping, I have to group, then I take out a GCF, and then I regroup. Another one would be Xbox, my two terms. The fourth I'm using is difference of two squares, then perfect trinomial. And lastly, AC method. where I have to multiply the A and the C to add to be the B value. And then I bring down and bring down. I find my two factors. And now I group, taking out a GCF and regrouping. And one more thing. On this problem, when we are going to do our keep, change, flip, we make our big fraction here because it's going to be multiplying. We Xbox the top and we put that in there in red. We Xbox the bottom and we put that there in the tealish blue. Then I take a GCF. This was like one of the most missed questions on chapter 9, knowing that this is a GCF. Just want to remind you of that. And then the top, I take out a GCF here so that I can Xbox it and finally take that out. And then we go ahead and factor out our matches from top to bottom and see what we have left over, right? Then I see that 9 and 3 can reduce because 9 is just 3 times 3, so I can get one of those 3's. So my final answer is x plus 5 over 3x. Thank you, Grace, and thank you, Ella, for catching my little boo-boos and helping me to fix that up and to re-record. Again, I'm so grateful for you guys. You are amazing, never going to be replaceable. Bye. Hello, my algebros. As we know, we're all getting a little tired, so I have a few corrections that I'm just throwing back on the back of this video. And so the first one is number 26. Thankfully, this is a negative here, and so I needed to change that a little bit. When I have a binomial times a binomial, I'm going to use box, FOIL, or stack. I choose to use box. I box it out, and then I go ahead and combine those like terms, right? That was chapter 7 on multiplying polynomials. And next, I forgot to put in question number 29, where we graph this equation. So I'm going to use y equals mx plus b, so my y-intercept is 5. So I put that first, and my slope is negative 3, or down 3 over 1. Once again, that means that my 5 is right there, and my slope is negative 3 over 1, meaning I go down 3 and over 1 from that point. Oops, sorry. And then I, of course, connect the dots. Lastly, I need to graph my parabola here, and I do this by, here's my x and my y, and I need to find my vertex first, which is negative b over 2a, right? Again, I have my a equals 1, b equals 2, and c equals negative 1. And I go ahead and substitute those values into my vertex, solving for that, and I get negative 2 over 2, which is negative 1. So I have my first x value, and I substitute into my equation to solve for the y value, and negative 1 squared is 1. 2 times negative 2 is negative, 2 times negative 1 is negative 2, minus 1 gives me negative 2. Then I have my vertex, and I can graph that. I put points that are bigger, which are 0 and 1, and points that are smaller, which are negative 2 and negative 3. Getting to solve for 0 is always one of those favorite things, because that means that all the x's are 0, or it's just the y-intercept, right, when x is 0. And that, of course, mirrors over to the other side. And then I substitute 1 in for my equation. I could have used negative 3, but I went with 1 because it's a little easier. And I end up with 2, and that mirrors over. I go ahead and graph my points, and I label my axis of symmetry, and I put my maximum or minimum, which this is a minimum, and y is greater than or equal to negative 2. All right, you guys, so don't forget that your note card was due in class this week, right? So get it to me by Thursday. If you were absent, you need to come see me. And our Zoom meeting for extra help is going to be Friday, 10 to 11:30, and attendance is optional, but of course always favorable. Again, I guess I've loved having to have you this year, and I just pray you do great on the final and have a lovely summer. Talk to you soon. Bye.